rational function with a slant asymptote. This example is the graph of f of x equals x squared minus x plus 1 over x minus 1. And we want to go through all the steps to graph this rational function. So step 1 is to identify the domain of the function. So we're looking at the denominator. And we're saying, when does this not equal 0? So we set it not equal to 0 and we solve for x. Undo is we add 1 to both sides. So the domain then is all real numbers except x cannot be 1. So that means then we're going to have a domain restriction at that x equals 1. So our vertical asymptote then is at x equals 1. Then we'll find the horizontal or slant asymptote. So we're looking at the degree of the numerator and the degree of the denominator. So the degree of the numerator is 2, and the degree of the denominator, degree of the denominator is 1, which means it's exactly, the numerator is exactly 1 more than the denominator by 1. So we have a slant. So we have to do long division. So we're going to take these two polynomials and divide them. So this will be underneath, and this will be outside in long division. So we say, how many times does x go into x squared? So off the side, x squared divided by x is x. Multiply it. X times negative 1 is negative x. X times x is x squared. Change the signs. And we get 0, 0, bring down the 1. X cannot go into 1, so this is my remainder. So we only work with what's up on top. So our equation for our slant is what's up on top as y equals x. Next is to find the x-intercepts. The x-intercepts are the 0 of the numerator. So here's our numerator, x squared minus x plus 1. We set that equal to 0 and solve for x. So we try to factor it first. We use the chart method. What are the factors of 1 that add to negative 1? And negative 1, that is not factorable, so we have to use the quadratic formula. Negative b plus or minus b squared minus 4ac all over 2a. Reduce it, 1 plus or minus 1 minus 4 over 2, which is going to give us a negative, right there, a complex number, so there is none. No x-intercepts are on this graph. Y-intercept, we set the function equal to 0 and solve for x. So here's our function. Just replacing that f of x with y. Let x equal 0. So 0 squared minus 0 plus 1. over 0 minus 1 is 1 over negative 1, which is negative 1. So you have an ordered pair of a y-intercept of 0, negative 1. Now we test for symmetry. So here's our original equation. We want the original back when we test it. So replace the y with a negative. Not the same, so no x-axis symmetry. Replace the x with a negative. Simplify that. We don't get the original back either. Last one, origin. Simplify in here. Don't get the original back either. So no symmetry. I'm going to hold off on finding the additional points for right now and start graphing these pieces. So go back up to the top. Look at your asymptotes. You have a vertical asymptote at x equals 1, and then a slant at y equals x. Y equals x. So you have a vertical VA at x equals 1. You have a slant asymptote at y equals x. That means you have no horizontal asymptote. That's none. X-intercepts, we had none. Y-intercept was at 0, negative 1. All right, let's graph what we have so far and then find additional points if need be. So I'll scale it by 2. So this is 1, 2, 3, 4. All right, vertical asymptote on the x-axis, x equals 1. Slant asymptote has a y-intercept of 0 and a slope of 1. There's my slant. Horizontal and x-intercepts are none. Y-intercept of 0, negative 1. And now we just find a few additional points. So we know this point of 0, negative 1. So something's going to happen down in this region. So now we just evaluate the function. So I'd say maybe evaluate it for 2. See what happens when x equals 2. So I'm going for 2. So 2 squared minus 2 plus 1 over 2 minus 1. PEMDAS, 4 minus 2 plus 1 over 1. 4 minus 2 is 2, plus 1 is 3, over 1 is 3. So over 2, up 3. And if we find a few additional points around here, what's going to happen is there's going to be a curve right in between those two asymptotes in the green and the blue. And then down here, there's going to be another curve between these two asymptotes. Those asymptotes help guide those curves. and that's how you graph that function.